subscribe to our channel and hit the bell icon so that you know when live we go. Hello and welcome to the weekly series of Indian Express Explained section discussion session. The idea here is to pick on news from the explained section of Indian Express that has not been covered already in the DNS. This series is to supplement the DNS. So we pick up news here, avoiding duplication congruency with the DNS. Keeping this in mind, we are going to take 3 news for discussion in this session. This is one of the explained article that appeared last week. What are the 2 missions that NASA has selected for exploration of Venus? Well, NASA has selected 2 missions to the planet Venus, which is Earth's nearest neighbor. The missions are the Vinci Plus and Veritas. These missions have been just cleared and they will be conceptualized, built, and finally launched. There is an Before we get into those missions and as to why there has been sudden increase in the interest in the planet Venus, let's talk about basics of the planet Venus. The first 4 planets in the solar system, Mercury, Venus, Earth and Mars, these are solid surface planets. The outer planets are gaseous. Venus is almost the same size as that of Earth and sometimes termed as twin of Earth. But this twin of Earth is highly unlike Earth. The atmosphere of Venus is composed of around 95-96% of carbon dioxide gas. Carbon dioxide is a very strong greenhouse gas, so you can understand the extent of greenhouse effect that is being operated in the planet Venus. Because of volcanic eruptions, there are sulfur compounds in the atmosphere of Venus as well, and these are in the form of sulfuric acid clouds. Because of presence of these sulfuric acid clouds, the atmosphere is very acidic. So acidic that it surpasses the pH scale. But these sulfuric acid clouds, they kind of envelop the Venus. So the conditions are extreme at the top. As you move down, the condition is not that very extreme. From the past mission to Venus, we already know that around 80% of the surface of Venus is composed of flat plains, and these plains are of volcanic origin. Because of this thick sulfuric acid cloud which is enveloping the atmosphere of the Venus, the planet appears very bright. In fact, it is the second brightest object as seen from the surface of the Earth after Moon. The brightness basically comes because of reflection and scattering of light from the thick cloud. The atmosphere is very dense at Venus, unlike Mars. The atmosphere of Mars is thinning down, but the atmosphere of Venus is still very thick, and it is largely carbon dioxide gas having high extent of greenhouse gas effect. So much so that it is the hottest planet in the solar system, despite being at the second number after Mercury. One very peculiar thing about Venus is that it has the rotation period longer than the revolution period or the orbital period, meaning it takes more time to rotate along its axis than orbiting around the Sun. The time of rotation around its axis is around 243 days, and the time of revolution is around 224.7 days. This high rotation period along the axis is not unique to Venus. In fact, this is the case for Mars as well. And the reason for this is their closeness to the Sun. The Sun pulls these planets, Mars and the Venus, very strongly. So they are not able to freely rotate as much as the other planets. So their time of rotation is very high. Another very peculiar thing that still puzzles the scientists is the retrograde rotation of the planet. It spins around its axis in the direction different from other planets. It rotates east to west. And that would mean that the Sun would rise in Venus in west. The reason of retrograde rotation is not known very well to this day, although there are many theories. One of the theory is that because of some asteroid or meteorite collision, the direction changed. But if the direction would have been changed because of a collision, that must be a very powerful collision, causing a high impact, forming a crater on the surface of Venus. But we have found the evidence of no such big crater on the surface. So the theory is that everything melted down. Because of intense volcanic activity, there has been spread of lava forming flat plains. So the crater is gone. Another theory regarding this retrograde rotation is that the axis of the planet has gone upside down. So it is not having a retrograde rotation. Actually, it is rotating in the same direction as other planet, but it is rotating upside down. So it looks as though the planet is rotating in opposite direction. Why it is rotating upside down? Why the axis has gone in the opposite direction? One of the theory is that because of intense atmospheric density, there are waves in the atmosphere, and those waves, along with friction acting at the mantle, they together have caused unbalanced force on the planet, resulting in the planet going upside down. And there are yet other theories which explains this retrograde rotation, but we do not have a final conclusive reason as to why Venus is rotating in opposite direction. Venus, by the way, does not have any moon, and the planet does not have any global magnetic field. Although there are magnetism on the rocks on the surface, but it does not have the magnetic field in the manner and the way that the planet Earth has. Now let's talk about the missions to the planet Venus. Missions to planet Venus was started by Soviet Union, and Soviet Union sent series of mission to planet Venus in the Venera series. They have sent many 12, 13 missions under the Venera series. The first one was in around 1960-61, but because of planet's harsh condition, these orbiters they could not survive for long. Then catching up very soon in 1962, NASA sent a flyby that was named as Mariner 2 because Mariner 1 failed. In the Venera series, Venera 8 was a lander of Soviet Union. It was sent in 1972. But because of the harsh condition, it could communicate only for 20 minutes. After this, Soviet kept on sending more missions in the Venera series and other missions, and they did it almost till 1990, almost the time when the Soviet Union collapsed. Once it collapsed, the acumen of Soviet Union in the space science also started to fade away. And this was the time when NASA started shifting its focus on the planet Mars. Because any mission on planet Mars will have a greater data return. The mapping can be done very smoothly because the atmosphere is thin and the condition is not extreme there. But however, some name of NASA's mission to planet Venus you must remember, Galileo. This is NASA's mission, not of European Space Agency. The name of European Union's global positioning system is Galileo. But this Galileo was a flyby. Cassini sent in 1997 was also a flyby, so was Messenger of 2004. Flyby meaning it is not going to orbit, it's just going to pass by the planet in their onward journey. The destination of the mission is somewhere else. But on their way from Earth to that destination, they will cross the region in and around Venus, and hence they can collect some data from Venus. That kind of mission is called as flyby. But NASA had dedicated mission known as Magellan mission, and this has collected lots of data concerning the atmosphere and the surface of Venus. European Space Agency had an orbiter called as Venus Express during the duration of 2006-2014. Presently, there is one and only one mission operating full-time dedicated for the planet Venus. That is the mission of Japan. The name of the mission is Akatsuki mission. ISRO has a planned mission to Venus known as Shukriyan. As we have discussed, in 1990s, the acumen of Soviet Union in space science started to fade away, deteriorate, and NASA started to shift its attention to the planet Mars. So Venus was kind of very neglected planet in our solar system. Once upon a time, there were too many missions from Soviet Union, and now is the time when we have only one mission which is operational for planet Venus. That is Japan's Akatsuki mission. Although there are others which are acting as flyby, for example, Solar Parker probe, which is a mission to study the sun, but it is crossing by very close to planet Venus, so it is also collecting some data from Venus. So in that sense, there are other flybys as well, but that is not dedicated mission to study the planet. The dedicated mission to study the planet is one and only one presently, that is Japan's Akatsuki mission. But now the interest has regenerated in the planet Venus. Question is why? First of all, there is a sense of presence of life on the planet. Recently, there have been many findings and reports that is hinting towards presence of phosphine gas on Venus. In 2017, while studying the Venus atmosphere using James Clerk Maxwell telescope, it was reported that phosphine gas is present in the atmosphere of Venus. In 2019, using Atacama Large Millimeter Array Facility in Chile, it was confirmed that the study of 2017 was correct. You see, it means a lot. If indeed there is phosphine gas in the atmosphere of Venus, then indeed there would be life. Because phosphine gas is a biosignature gas. Biosignature gases are those that hints the presence of life. Phosphine gas has no abiotic false positives, meaning nothing but life can only naturally produce gas on any planet anywhere in universe. Phosphine gas does not occur naturally without the presence of life. Not in the rock, not in the salt, not in the ocean, not in the atmosphere, nowhere. Either we can produce it in the laboratory or it will be the product of living entity. So it does not have any abiotic false positive, meaning it will not be present in the abiotic source. Hence, it is a biosignature gas. It signifies the presence of life. Biosignature substance is any substance, any element, isotope, molecule, gases molecule, anything that provides scientific evidence of past or present life. For example, phosphine gas. This gas is associated with anaerobic ecosystem. Like phosphine, there are other biosignature gases: methane, nitrous oxide, methyl bromide, methyl chloride, hydrogen sulfide, carbonyl sulfide, phosphine we have talked about, sulfur dioxide. All these gases are considered to be biosignature gas. So if we can conclusively say that phosphine gas is present in the atmosphere of Venus, then we can also conclusively say that life is present on the planet Venus, because artificially no would be there in the planet Venus to produce phosphine gas. But scientists have been pointing out to be cautious while assuming that phosphine gas is present, although there have been different studies in different time frame pointing out towards the presence of phosphine gas in the atmosphere, but we need to be 100% sure before we take our excitement to the next level. So this is one reason as to why there have been recent regeneration of interest in the planet Venus. It also has been realized lately that studying planet Venus will be worthwhile. We do have evidence for the fact that Venus started out just like Earth in the early solar system. But on Earth, carbon is mainly trapped in rocks. On Venus, at the later stage, there has been somehow escape of carbon into atmosphere. And presently, approximately 96% of carbon dioxide makes up the atmosphere of Venus. And this has led to runaway greenhouse gas effect, pushing the surface temperature to as high as 470 degrees Celsius. And you know what's happening on Earth these days: climate change, the greenhouse gas effect, and which is the better place to study greenhouse gas effect? If we can understand how this runaway greenhouse gas effect happened on the planet Venus because of runaway carbon escaping into the atmosphere, we can take this as an extreme case of studying greenhouse gas effect. On planet Earth, because of greenhouse gas effect, the temperature is increasing and there is a threat of carbon getting escaped into the atmosphere. So if we can understand what was the break point at which the running away of carbon into atmosphere started, we can understand as to how the greenhouse gas effect is going to impact our planet. This understanding will help us figure out this Venus-Earth difference. These two twin planets of almost same size are starting almost the same way. Once upon a time, Venus had oceans, rivers and streams just like Earth. So did Mars. On Mars, we have solid proof of rivers running through. But because the Venus is shrouded by cloud, covered, enveloped by thick cloud, we do not have a high resolution picture of surface of Venus like Mars. But those solid proofs can come as we send more powerful mission to the planet. And then we can understand as to how planets evolve in general and what are the conditions leading to habitable conditions evolving on our planet. This is crucial to understand if we want to understand exoplanets. We are looking for life beyond our solar system. We are looking for life on Earth-like planet called as exoplanets. If we understand the conditions, the prerequisites for habitable conditions evolving on our planet, then our search and study of exoplanets will also improve. Considering these points, NASA has announced two missions to the planet Venus. The first one is the Vinci Plus. Considering these advantages, investigation of noble gases. Considering these advantages, as the name suggests, it will be mostly the deep atmospheric study of Venus. The Vinci will be a descent mission, meaning a probe will be dropped through the atmosphere of Venus. And as it is dropped, it will continuously take measurement on its descent. The main aim of the mission is to find out the composition of the atmosphere in detail. We know, yes, that around 95-96% of the atmosphere is carbon dioxide. And we also know very well that there is a thick cloud cover at the top at around 50 kilometer. But we do not know the trace elements present in the atmosphere very well. And this information is crucial to understand how atmosphere ended up in its present state. As the probe descends down further, it will measure the weather properties such as the wind speed, the temperature, and the pressure in the lower region of the atmosphere. And when it comes close to the surface, it will also take high resolution image of the surface. We have very high resolution of image of the surface of Mars because the orbiters can take very high resolution images. That is not the case for Venus. Venus, because of its thick cloud cover, reflects most of the visible light. So, observing the surface of Venus from the Earth or from the orbit is not very practical. You cannot do it using visible light, you cannot do it using ultraviolet light because the atmosphere of Venus, being so dense, will absorb the ultraviolet radiations. And it is also not very practical to send a rover down on the surface. Because of high temperature, it will be trampled in no time. But we do have some low resolution image of the surface of Venus taken by NASA's mission Magellan in early 90s. The Vinci probe will do the imaging of the surface in the region of infrared light. I hope you are aware that Earth emits radiation in the infrared light region, particularly in the far infrared region. You have ultraviolet region, you have visible light region. If you reduce the energy, you have infrared region. If you reduce the energy further, you have microwave region, and then you have radio wave region. Infrared can further be divided into near infrared, mid infrared, and far infrared. Near infrared is the band that is nearer to the visible range, and far infrared is the region that is further from the visible range. It is in the far infrared region that the Earth emits radiation. The Vinci probe is going to do the imaging of the surface of Venus in the infrared region. This imaging will help us understand a physical feature on the surface of Venus called as tesserae. They are basically deformations on the surface, and this deformation points to the existence of plates, tectonic plates. The Vinci, of course, will do the imaging of the surface of the planet Venus when it approaches it in the infrared region. But while it is descending through the atmosphere, it will use QVIS. It will use the compact ultraviolet to visible imaging spectrometer to determine the nature of unknown ultraviolet absorbers in the Venus atmosphere. That will help us know the noble gases, the trace gases, and the detailed atmospheric composition of the Venus. The other mission called as Veritas. Veritas stands for Venus Emissivity, Radio Science. In SAR, SAR here stands for Synthetic Aperture Radar, Topography and Spectroscopy. See, as the name suggests, Venus emissivity, you are going to deal with the radiations which is emitted out of the surface, which will be in infrared region. So first of all, this orbiter, Veritas, is going to be an orbiter. The Vinci Plus is going to be a descent probe, but Veritas will be an orbiter. And this orbiter will try to map the Venus surface in greater detail than what we know presently using infrared surface emissions. See, different substance emits different kinds of radiation, and the radiation emitted out of a substance or a region, that is signature of its composition, its constituent. And by monitoring infrared surface emission, we can know that rock type, the chemical composition of the rocks beneath. This is extremely important because such observations will shed light on Venus' geological history. It will help us understand the climatic evolution on that planet. And it will also make us clear regarding the plate tectonic movements or the volcanic activity on the planet. If the plates are diverging, then new material will come up. So the composition on both sides of a divergent plate must be the same. Using these indirect methods, we can learn a lot about geological aspect of Venus. Apart from infrared surface emission radiation measurement, as the name suggests, Veritas will also do the observation using the radio waves. The radar technology, as you understand, is used very often even in the Earth observation satellite that is used for topographical measurement. On a very fundamental level, radar technology operates like this. The radiation, either in radio wave or microwave, is sent out, and then it bounces back from the obstacle, and you measure the time which it takes for the radiation to come back. Depending upon that, you measure the distance. So, if beneath the area is not plane, then the time it will take for the radiation to come back will be different at different point. And based on that, you will know the length. And based on that, you will know the topography. This is how the radar system works. And as you would be aware that the radar system operates even in the cloudy weather, even in the windy weather. So it will operate through the thick atmosphere of Venus as well. Synthetic aperture radar actually is used for high resolution. Since the atmosphere is thick, temperature is high, normal radar system will not work here. Because the radiation that will go back, that will change in wavelength. Because of high temperature. So there will be problem with the resolution of your mapping. To overcome that, very strong synthetic aperture radar system is used. These missions, apart from many other things, will also help us to understand the Venusian surface. So we will understand whether it completely melted and reformed some 500 million years ago, according to a theory which should explain the absence of crater on the surface of Venus. Remember, we saw in the beginning of discussion of this topic that Venus has a retrograde rotation, and sometimes the reason cited for this fact is a meteorite impact. But an impact that reversed its direction of rotation must be a huge one, and it must have left some crater. But the absence of crater is generally explained by the theory that the surface of Venus completely melted and it reformed. But that theory can only be proven if we can find the evidence of volcanic lava layer. And when we complete the mapping through infrared radiation, we will get to know if there is volcanic lava layer. And then perhaps we'll have a better understanding as to why Venus has retrograde rotation. All in all, we'll understand the planet better. We will understand the impact of climate change on our planet Earth. We will understand as to how the planet evolved and how planet becomes habitable. That will help us in our search of exoplanets. In total, our understanding of this universe will increase by sending these missions to Venus. The next article that we are going to pick up is this: what puts lions and tigers at coronavirus risk? See, the thing is, lions are dying all over the country. A lioness has died at Vandalur Zoo in Chennai. A 10-year-old tiger also has died at Ranchi's Bhagwan Birsa Biological Park. At the National Institute of High Security Animal Disease at Bhopal. So the situation begs a question: are lions and tigers particularly vulnerable to coronavirus infection? To answer this question, first we have to understand and appreciate that the first step in the infectivity of a virus is the virus coming close to the cell of the host and latching onto it, binding with the cell of the host strongly, so that the process of virus getting inside the host cell can be initiated. Otherwise, the virus will be flowing into the bloodstream and it will not have the chance to get inside the cell. Getting inside the cell is extremely important because it is inside the cell, in the cytoplasm of the host cell, that the virus multiplies. And that multiplication will not happen unless it enters the cell. So infection will not happen unless it enters the cell. And it cannot enter the cell unless it stabilizes on the surface of the cell. So this same question can be put alternatively. Does the coronavirus latches up strongly on the cell surface of lions and tigers? If it does, then they are vulnerable. If it does not, they are not vulnerable. Because the process of infection begins by attaching of the virus on the surface of the host cell, so the spike protein on the surface of the virus is the defining feature of coronavirus infection. Virus binds on the surface of the host cell through the spike proteins as shown here. There are multiple proteins present on the surface of the host cell serving multiple purposes. So the virus will try and test different proteins and see where it fits. And wherever it fits, it will stabilize itself at that site. It is a matter of chance that the ACE2 protein, which is naturally present on the surface of human cell, this protein acts as the doorway for coronavirus infection. ACE2 stands for angiotensin converting enzyme 2. Angiotensin converting enzyme 2, it's a surface protein because it's present on the surface of the cell, as you can see from this diagram. The purpose of ACE2 protein on the surface of human cell is to regulate blood pressure. When the blood pressure increases and it is needed to be brought down, then ACE2 protein is utilized. ACE2 protein brings down the blood pressure level in human body. But the design, the construct, the structure of ACE2 protein is such that it fits. It acts as a good fit for the spike protein of coronavirus. So coronavirus comes and it attaches its spike protein with the ACE2 protein on the surface of human cell. Once the virus stabilizes itself all well on the cell, then it begins to enter into the cell. And then the replication process of the virus will happen inside the cell. Now the same question can be asked alternatively as, does lions and tigers have greater amount of ACE2 protein expression at the outer membrane of their cell? If yes, then they are vulnerable to coronavirus infection. If no, then they are not vulnerable. Well, it has been found in many studies that domestic cats and their bigger cousins, of course, the tigers and the leopards, they have been found, and in many cases, it has been estimated theoretically that they express ACE2 protein more, significantly more than other species. So we have zeroed down to the answer to the question we asked in the beginning. Since the domestic cats and their cousins, the tigers and the leopards, they have more expression of ACE2 protein, so they will be more vulnerable to coronavirus infection. More so, the structure of the ACE2 proteins in cats are quite similar to that of humans. There has been a study done in the University of Bologna in Italy. They collected tissues from 6 cats and a tiger, and they found wide expression of ACE2 in the gastrointestinal tracts. ACE2 protein in human beings, they are largely found in lungs, kidneys, liver, and GI tracts. So according to this study, in the GI tracts, these cats and the larger cousin of cats, they also have excessive expression of ACE2. And since there is a structural similarity in the structure of ACE2 protein in human beings and that in cats, it can be safely assumed that they are also more vulnerable to coronavirus infection. There is an open scientific peer-reviewed journal called as PLOS Computational Biology. This journal is mostly for computational biology. In December last year, a study was published in this journal looking at the ACE2 receptors of 10 different species. And they tried to find out the affinity factor for binding of spike protein of coronavirus to the ACE2 protein of these species. How the affinity will be decided? The greater the structural fit of spike protein with the ACE2 protein, the greater affinity will be there for binding on the site and hence greater infectivity. And based on this computational biological study, it has been found out that the most vulnerable species to coronavirus infection after human beings are ferrets, followed by cats, followed by civets. Cutting long story short, Are lions and tigers particularly vulnerable to coronavirus infection? The short answer is yes. The long answer is yes, because they have greater expression of ACE2 protein, which acts as the doorway for coronavirus to enter inside the host cell. Now let's take up this explained article, How Indians See the Economy. This article is in the context of the Consumer Confidence Index that is released by RBI. See, in Indian economy, consumption expenditure accounts for almost 60% of India's GDP. So domestic consumption expenditure is considered to be the major driver of Indian growth and development. And what's the driver for the consumption expenditure? Confidence. Confidence in economy, the confidence of customers in the Indian economy. If the customers are optimistic about the current and the future economic state of the country, then they would spend more money, leading to increase in GDP. On the other hand, if the confidence is low, the customers are pessimistic, then that would lead to decrease in consumption expenditure and hence will negatively impact the GDP growth rate. And this is exactly what has been happening presently. RBI has left no stone unturned to increase the money supply in the market. The banks have been flushed with money, but the banks do not find much taker of the loan. The customers are not investing. So the increased money supply created by RBI is not resulting into credit creation. Why? Because customer confidence is low. Hence, it's important to measure the customer's confidence in a country to understand the prospect of economic growth. And the way it is measured in India is through Consumer Confidence Survey. The Consumer Confidence Survey is conducted by RBI in 13 major cities in India, and it approximately covers around 5,000 respondents. The survey measures consumer perception both of the current economic situation and the future prospect on five variables: economic situation, employment, the price level, income, and spending. Based upon the two areas the survey is done on, the current economic situation and the future prospect, current situation index, and future expectations index. The current situation index measures the change in consumer perception over an economic issue in last 1 year. The customers are asked their condition on these parameters compared to the last year, while the future expectation index measures what customer thinks about the same variables 1 year ahead. Numerically, if the consumer confidence index is above 100, that means people are optimistic. A score of below 100 signals a pessimistic perception. This is the snapshot of Consumer Confidence Survey of May this year. You can see that the current situation index given in red line is very poor. It is below 50. And even the future expectation index of meaning the expectation of economic situation 1 year ahead is also pessimistic, below 100 score. So the customer confidence is at all-time low. If you see the parameters like economic situation and employment, the current perception, which is compared to the last year's perception, has decreased. And the expectation also has decreased on these two parameters. The sentiment on the price level is also pessimistic, although it has improved compared to last year. Sentiment on income is also negative, although this also has improved compared to last year. On spending, if you see, the sentiment is positive, seen in green, but since the arrow is pointing downward, that signals that although the sentiment is positive, but there is a sign of deterioration compared to the last round. You do not have any upward green arrow in the entire survey result. So the survey has highlighted that the Indians have cut down on their expenses presently. They are likely to do so in the future as well. The decline in the consumption expenditure is mainly due to weak customer confidence and sentiment about Indian economy. Their perception about present and future employment situation also remains bleak. Unless customer confidence improves, consumption expenditure will not pick up. And unless the expenditure picks up, the private sector will be reluctant to undertake investment, hampering job creation and economic revival prospect. Hence, one of the biggest takeaway from this survey is to boost consumer sentiment and confidence. This is possible through counter-cyclical fiscal policy, accompanied by renewed push to create jobs and enhance the income levels. Now we will have a small test. There are statements given on left hand side and there are inference based on those statements on the right hand side column. You have to assume that the statements are correct. And on that assumption you have to check if the inference are correct or not. The first statement is cats and tigers are particularly vulnerable to SARS-CoV-2 virus infection. If this is a statement, then the given inference is correct or incorrect. This is what you have to identify. I'll read the inference and I'll give the answer in next 5 seconds. So you have to quickly guess the answer in your mind before I give the answer. If cats and tigers are particularly vulnerable to SARS-CoV-2 infection, then it means that they have greater expression of ACE2 protein. The inference is correct because as far as we know, ACE2 is the doorway for the coronavirus to get inside the host cell. So if they are vulnerable, that means that the ACE2 protein expression must be high. So this is the correct inference. The next statement is Venus has retrograde rotation. If Venus has retrograde rotation, it means it rotates east to west. The inference is that the sun rises in the west in Venus. Since it rotates east to west, then obviously the sun will rise in the west. This inference is also correct. Earth rotates west to east. So the sun rises in the east. The next statement is Venus has a thick atmosphere and dense cloud cover. If this is the case, then can you draw this inference? Orbiter around Venus with radar system won't work. Well, the radar system that uses the radiation in the wavelength range of radio wave and microwave, they are transparent to atmosphere, they are transparent to winds. You know that very well that the radar system works in any climate, any time, 24/7, 365. So the radar system operation will not be hampered by the thick atmosphere or the dense cloud cover in the Venus. This inference is incorrect. Phosgene gas is present in the atmosphere of Venus. Now, this is not 100% sure, and researchers are asking us to be cautious on this. But as I told you, you have to assume that the statement is correct, and based on that assumption, check if the inference is correct. If phosgene gas is present, then life must exist on Venus. There are only two ways to produce phosgene gas. It is produced naturally because of living ecosystem, or it can be produced artificially by human beings in laboratory. Assuming artificially nobody is creating phosgene gas in Venus, there is only one way it can be produced through existence of life form. So life exists on Venus. This is correct inference based on this statement. If you look at it individually in an isolated manner, this will not be a sure shot correct statement because we do not know it yet. But based on this statement, this inference is correct. Venus is the hottest planet in the solar system. The inference for this statement is greenhouse gas effect is very high in Venus. This inference is absolutely correct because the way a planet can get hotter are because of either greenhouse or because of the heat coming from the sun. Venus is not the first planet closest to the sun. So if it is hottest, then surely distance from the sun is not the factor for this. Heat coming from the sun is not the factor for this. It must be hottest because of the greenhouse gas effect. So this inference is again correct. Customer confidence is low in the economy. If this is the statement, then based on this, can you say consumption expenditure will decrease? Consumption expenditure will have a direct correlation with the customer's confidence, the sentiment regarding the economy. So this is absolutely correct. If the confidence goes down, then the consumption expenditure will also go down. But if I reverse this, then you tell me in the comment section, will the inference still be correct? If this is the statement and this is the inference, then will the inference be correct? If consumption expenditure is decreasing if consumption expenditure is decreasing in the economy, this is a statement. Then can you say that the customer confidence is low in the economy?